discuss neuromuscular transmission. As an axon reaches the muscle, it leaves its myelin sheath. It forms expanded terminal buttons, also known as end feet, which fits in the junctional fold of motor end plate. This terminal button contains vesicles that has neurotransmitter, mainly acetyl. This motor end plate is the thickened portion of the muscle membrane. The muscle membrane is known as postsynaptic membrane, while the nerve endings, the terminal buttons, are known as presynaptic membrane, and the space between the presynaptic and postsynaptic membrane is called synaptic cleft. This whole structure is known as neuromuscular junction or myoneural junction. In case of skeletal muscle fiber, one nerve fiber attaches to one muscle fiber. In case of smooth muscle fiber, the nerve fiber branches and forms connection with many muscle fibers. Synthesis of acetylcholine. Free choline comes to the presynaptic membrane from extracellular fluid. Acetyl coenzyme A is present in the mitochondria of the presynaptic membrane, and ATP and glucose are there in the cytoplasm. This all combine together and form acetylcholine in the presence of enzyme choline acetyl transferase. Now, when acetylcholine is released in the synaptic cleft, it is degraded by the enzyme acetylcholine esterase to choline and acetate. This choline is again reuptake by the ECF and it goes back to the presynaptic membrane. Now let us go to the process of neuromuscular transmission. When an action potential arrives at the terminal buttons, there is opening up of calcium channels. These are voltage gated calcium channels which leads to entry of calcium inside the buttons. Due to entry of calcium, there will be release of acetylcholine by process of exocytosis. When the acetylcholine is released in the synaptic clefts, it attaches to the junctional folds on the motor end plate by its acetylcholine receptors. This leads to opening up of sodium channels and entry of sodium inside the motor end plate. This will lead to depolarization and production of local end plate potential. This local end plate potential will open up more sodium channels and produce a propagated action potential leading to contraction of muscle. Now, the released acetylcholine in the synaptic cleft is degraded by the enzyme acetylcholine esterase, and the choline component is taken up by the presynaptic membrane for formation of new neurotransmitter. At rest, small quantum of acetylcholine is released from the presynaptic membrane and produced a miniature spike potentials in the postsynaptic membrane of 0.5 millivolt amplitude. These miniature spikes are known as miniature end plate potential. This miniature end plate potential is dependent on calcium concentration. Let us now discuss some disease related to neuromuscular transmission. The most common is myasthenia gravis. Here, antibodies are formed against the acetylcholine receptors on the motor and flesh. So, even if normal release of acetylcholine is there, it does not produce action. It will lead to easy fatigue and it mainly affects the extraocular muscles. When the disease is in severe form, it affects the respiratory muscles also. The next is Lambert-Eaton syndrome. In this disorder, there are antibodies against the calcium channels in the presynaptic membrane. So, enough calcium is not there and so acetylcholine release is decreased. Whenever there is repeated stimulation given, calcium concentration builds up in the presynaptic membrane and sufficient amount of acetylcholine is released. This affects the proximal group of muscle. Clinically important drugs which act on the neuromuscular transmission. The first group is the one which inhibits the release of acetylcholine from the presynaptic membrane. The classical example of this is botulinum toxin. Now, there are certain group of drugs which block the receptors of acetylcholine on the postsynaptic membrane. These drugs compete with the acetylcholine released from the presynaptic membrane and thus does not allow the acetylcholine to bring about its action. The drugs are D-tubulin and galectin. Now, the third class which is acting on the postsynaptic membrane are persistent depolarizing drugs. These will bring about depolarization for longer duration and will cause blockage of transmission. The next impulse will not occur. The classic example of this is succinylcholine. The fourth class of drug which acts on the neuromuscular transmission and which is clinically important is acetylcholine esterase inhibitors. This class of drugs acts on the synaptic cleft and prevents the breakdown of acetylcholine. So, the concentration of acetylcholine builds up in the synaptic cleft. So, the acetylcholine now will combine with the receptors whatever present in the junctional folds. By this way, the acetylcholine esterase inhibitors bring about reversal of the blocking action of D-tubulin and galectin. The example of these drugs are neostigmine and idursulfase.
Important points to remember. Define neuromuscular junction. It is a junction between motor nerve fiber and muscle fiber. Enumerate difference between neuromuscular junction of skeletal muscle and smooth muscle. In skeletal muscle, the junction is between one nerve fiber and individual skeletal muscle fiber. Here, the neurotransmitter is acetylcholine. In smooth muscle, junction is between one nerve fiber with many smooth muscle fibers. Neurotransmitter is acetylcholine or norepinephrine. Presynaptic membrane contains varicosities which has synaptic vesicles. What is miniature end plate potential? Small quantity of acetylcholine released at rest due to random Brownian movements. Some impulses come to nerve terminal. This causes minor depolarization spike which is about 0.5 millivolt in amplitude. This is called miniature end plate potential. What is end plate potential? Binding of acetylcholine to the postsynaptic receptors causes influx of sodium ions and generation of local potentials known as end plate potential. What is junctional potential? When smooth muscles are excited by a nerve stimuli, discrete partial depolarization occur that are similar to end plate potential. These are called as excitatory junctional potential. Similarly, when smooth muscles are inhibited, hyperpolarization occurs. These end plate potentials are known as inhibitory junctional potentials. Name drugs that inhibit release of acetylcholine from presynaptic membrane. Botulinum toxin. Name drugs that block transmission at neuromuscular junction. Group of drugs called as curariform drugs block the transmission of neuromuscular junction. D-tubocurarine blocks the action of acetylcholine on the muscle fiber acetylcholine receptors. Drug causing persistent depolarization at postsynaptic membrane, succinylcholine, decamethonium. Name drugs that stimulate the neuromuscular junction by inactivating acetylcholinesterase. Neostigmine, physostigmine, diisopropyl fluorophosphate.